Okay, now let's look at example 3. The current in the wires of a circuit is 60 milliampere. If the voltage impressed across the ends of the circuit were double with no change in its resistance, what would be the new current be? Okay, so here we have wires with 60 milliampere current, and then it says here if the voltage is double, so the voltage at the end, and with no change in resistance, what is the new current? Okay, so now we have a current here 60 milliampere, and then dia bagi tahu at the end the voltage is double, so meaning that initially voltage adalah just 1 V lah, and then at the end the voltage will be double. Maybe we just label as V2 V1, so double meaning that 2V. So we want to know what is the current, the new current here, so I2, and then this one will be I1, and it says here resistance is constant, so maksudnya resistance constant, right? So this one is very easy, we just need to use the ratio. So using Ohm's law, V is equal to IR. Since resistance is constant, so meaning that initial and final, so R1 and R2 will be constant, right? So meaning that V1 over I1 will be equal to V2 over I2, and I2 ni lah yang kita mau cari dekat sini. So just masukkan the value. V1 adalah V, I1 is 60 exponent negative 3, and then V2 adalah 2V divided by I2. So this one you can cancel, so meaning that here I2 will be equal to 2 times 60 exponent negative 3, which is equal to 120 milliampere. So this one is for example 3. Okay, now let's look at example 4. Two students are performing a lab using length of wire as resistors. The two students have wires made of the exact same material, but student B has a wire that has twice the radius of student A's wire. If student B wants his wire to have the same resistance as student A's wire, how should student B's length compare to student A's wire? Okay, that was a long statement. So basically here we have two students. We have student A and student B. Okay, kita tengok information apa yang dia bagi tadi. Here dia bagi tahu dekat sini, so the two students have wires made of the exact same material. So same material meaning that, okay, so here same material meaning that, okay, resistivity sama, PA and PB will be the same. And then bagi tahu lagi dekat sini, student B has a wire that has twice the radius of student B's wire. So radius untuk student B adalah 2 kali ganda daripada student A, so meaning that 2R for student B and just R for student A. And then dekat sini dia bagi tahu lagi, if student B wants his wire to have the same resistance as student B, so dia mau dekat sini adalah same resistance, meaning that, okay, resistance A must be equal to resistance B. Okay, how should student B length compare to student A wire? So dia minta adalah what is the length of student B bila kita compare kepada student A. So maksudnya we want the ratio here, so we want the length of student B. Okay, now we have two information here yang kita boleh gunakan, resistivity and resistance. So we know that the formula for resistivity is P is equal to RA over L, because dia cakap adalah we want the same resistance, right? So kita rearrange this formula, which is equal to resistivity times with L divided by the area. Okay, area here, because this one is area for wire, right? So meaning that area for wire will be pi r square. Okay, so using this information that we have, meaning that resistivity of A, LA divided by the area is equal to resistivity of B, LB divided by the area here. And area dekat sini, okay, Miss terus masukkan lah, because I already tulis here, right? So it will be pi r square, pi r square. Okay, but here, okay, the radius untuk A is just r, untuk B is 2r. So masukkan PA LA divided by pi r square is equal to PB LB divided by pi 2r square. So kita boleh potong mana yang sama. Since resistivity sama, kita boleh potong this one. Then here kita boleh potong juga. So sekarang ni kita ada tinggal LA divided by r square is equal to LB. So this one will be 4r square. So ni pun boleh potong. So maksudnya dekat sini yang tinggal adalah, because we want this one kan, kita mau panjang wire untuk student B. So LB akan di sebelah kiri will be equal to 4LA. So this will be the solution for example 4. Okay, next one, example 5. So a wire 4 meter long and 6 millimeter in diameter has resistance of 15 milliohm. A potential difference of 23 volt is applied between the ends. So determine the current in the wire. Okay, so information that we have here. So this wire, okay, has a length of 4 meter and then diameter is 6 millimeter. So the resistance is 15 milliohm and then potential difference is 23 volt. So we want to find what is the current. Okay, so in order to find the current, this one is very straightforward. You use Ohm's law, V is equal to IR, since we have the value for resistance and voltage. So boleh masukkan V adalah 23, I, and then resistance will be 15 exponent negative 3, so milliohm, right? So the current will be equal to 1.53 exponent 3 ampere. Okay, question B. So determine the resistivity of the wire material. So we want to find the resistivity, which is this one. So formula adalah RA divided by L. And then area here, area kita, because it's wire, right? So area will be equal to pi r square. Okay, so this one, because we are given the diameter here, so ubah kepada radius, which is equal to, bagi dua lah, negative 3 meter. So masukkan dekat sini, resistance will be 15 exponent negative 3 and then pi darab dengan radius 3 exponent negative 3 square, then divided by the L, which is the meter, which is 4 meter. Sorry, the length, which is 4 meter. So resistivity will be equal to 1.06 exponent negative 7 ohm meter. Okay, so that will be the example 5.